Good afternoon and welcome back. We are going to pick up with what you just did. Let's talk about what you just did.
I guessed.
Other than guessing, let's talk about how we would do this. I think it was it 1/2 x cubed plus 2?
Yeah.
That's what I gave you guys, right? Okay, so we're looking for the inverse. Okay, and we should all know what the inverse is. Now, we didn't even talk about the notation the other day, but it's in your book. They write it as like f to the negative 1. That doesn't mean that it's to the power negative 1. That's just the notation that they use to represent the inverse function. So if this is the original function, this is what we call f inverse of x. Okay? So the idea is we got to come up with the inverse of that guy. And there's multiple ways to do this. One way would be to do that XY switch that we talked about the other day. The other thing would be just to kind of jot down like bullet points, like what's going on here, right? Like my order of operations, the very first thing that happens to x is we cube it. Order of operations. First we cube it, then we half it, and then we add 2. Do you guys agree that that's what the order of operations was? So if I was going to find the inverse, I'd want to do these same 3 things, except I would work backwards, and I would do the opposite of all of them. So if I started with some value x, instead of adding 2, I would subtract 2. Instead of halving it, I would double it. You guys agree? And instead of cubing, I would cube root it. The opposite of a cube is a cube root. So how would you have to write that I think I gave it to you in exponential. Taking something to the 1/3 power is the exact same as taking the cube root of that thing. So that's what you should have got, right? The other way you could have done this is you could have rewrote this. The original is y equals 1/2 x cubed plus 2. I'm going to do the xy switch. So everywhere I see a y, I'm going to write x. Everywhere I see an x, I'm going to write a y. And now I need to solve for y, right? Notice what the order of operations. If I want to get y all by himself, algebraically, what's the first thing I should do? Subtract 2 from both sides. Do you guys agree? Notice, what's the first thing I did here? The opposite of add 2, I subtract 2, right? That's what I'm going to do down here, subtract 2. So now I got x minus 2 equals 1/2 y cubed. What's the next thing I should do to get y all by himself? Take it times 2. And again, here I took half of it. I do the opposite of that, times 2. So 2x minus 2 equals, the 2 and the 1/2 are going to cancel. And then finally, instead of cubing it, I would cube root it. Like that and like that. So y equals the cube root of 2 times x minus 2, or 2 times x minus 2 to the 1/3 power. Okay, you should be able to do that for your 3.7 quiz, for your test. You should be able to find the inverse of a function, whether you do the whole XY switch or just kind of look at the order of operations. I want to take our original guy here, and I want to look at it graphically. So you might recall a long time ago when we started doing functions, I said there were 4 different ways we could represent them, right? One of them was to represent it verbally. Just speak a sentence or something like that, and you could represent a function. And then, of course, we could do the same with the inverse function. So an example of that would be, that's what we did to Tracy's house. Remember when we did that on Friday? That was just verbal. Like giving, well, we wrote it out, but it was verbal descriptions. Another way would be to do like a table or a chart of values. And there's actually an example of that. If I go to your textbook and I go to section 3.7, maybe. And there's an example here where it just gives like a chart. Like here's an x and an f of x and an inverse. I thought there was a better one than that. Something like that. Where they're just representing a function as a chart of values. We talked about that before. We also can do an equation. That's what you just did on your quiz, right? I gave you an equation. You came up with the equation of the inverse. And then, of course, we can have a function represented by a graph, which is like what I'd like to do right now. So what I want you to do is open your GeoGebra. And we are going to graph the original function, the one that was on your quiz. I'll go to font size and make it bigger. Let's graph 1/2 x cubed plus 2. I'm going to use 0.5 because that's the same as 1/2. 0.5 x caret 3 plus 2. That is my original function. Everybody got it? Okay, let's talk just looking at the graph of a function really quick. You look at the graph of something that may or may not be a function, and the question says, is this a function, yes or no? How can you tell very quickly if it's a function or not? Go ahead, Hannah. If it has one, you're ahead of me one step, I think, when you use the phrase one-to-one. We're going to talk about that in a second. How do you tell if it's a function or not? Vertical line test. If you draw a bunch of vertical lines and it only cuts through the graph one time, that tells you that every y value came from only one x value. Passes the vertical line test, it is a function. Okay? So, I'm going to come back to what you said in a second, Hannah. We're going to talk about what it means. If we've already established that it's a function, then we can also ask ourselves, is it a one-to-one function? We'll talk about that in a second. So, the first thing I want to do is, if this is our original, I want to be able to picture what the graph of the inverse would be. Now, I could type it in because we already solved for it on the quiz. But let's say I didn't even know what that was yet. So what I'd like you to do is I'd like you to make a line. Grab your line here. And we're going to make the line be the line that goes right at a 45-degree angle, right through the origin and 45-degree angle. So just pick out 2 points where the x and y are the same, like 0, 0, and I don't know, doesn't matter. Like 6, 6, for example. I want that line right there. It's the line y equals x is what it is. See how it cuts 45 degrees right through the middle of the quadrant there? And I'm going to erase my A and B point just so I don't have to look at them. Everybody have that line drawn? And then what I'd like you to do, just to make it look prettier, go ahead and right-click on it, on that line. Go to Properties. And I'm going to change the color of mine. I'm going to make it like a pretty orange. And I'm also going to go to Style, and I'm going to make it a dotted line instead of a solid line. I just want you to make it look different so that you don't think it's part of the function that we're working with here. We're focusing on that 0.5x cubed plus 2. But I want to have that line in there. So what we're going to do is we're going to use that line as a mirror or a reflection. If you can imagine this computer screen being a piece of paper, imagine being able to fold it right on that line and what it would look like if the green part, if this was like paint, for example, or a wet marker, and you folded it over, what would it look like on the other side if it showed up on the other side? That's what we're going to do. We're going to use it as a mirror or as a reflection line. So here's the little activity here. Make yourself a new point. So grab your new point tool and click somewhere on your f of x, your original function. That gives me point C. Everybody see point C? You got it on there? And notice what happens if you drag point C. See how it just locks into the function? So wherever you drag it, it's locked in. Then what I'd like you to do, once you have a point that's locked in on the curve, go to this reflect about a line. It's the third one from the right. Okay? We are going to reflect. I'm going to click on point C, and then I'm going to click on my orange dotted line, and a new point named C prime is going to show up. Oren will walk around and help you out if you get lost. Anybody struggling yet? You should now have 2 points. Mine are called C and C prime. Yours might also be C and C prime if you've been doing it the same as me. Now I want you to drag point C and notice where C prime, see how it follows it? Wherever you put point C prime is his mirror image, where the orange dotted line is serving as the mirror. And in particular, I want you to pay attention to the coordinates of point C and point C prime. And you should recognize something when you compare those two coordinates. And Alex is going like this with his fingers here. Notice that whatever C is, x comma y, C prime is exactly the same except it's y comma x. It flipped. But that's what we do when we have an inverse function, correct? The x's become y's and the y's become x's. Okay, so now to finish this off, and then I'll walk around and see how you're doing, I want you to go to your mirror point. That's my C prime is what it's called. I'm going to right click on my C prime, and there's this cool little feature that says trace on. You guys see that? It's going to serve, like as it moves now, it's going to leave its footprint. It's like you're turning the point into a marker. And now when you drag point C, notice that C prime leaves a trail, and it leaves a footprint of where it's been. And now you can see the full mirror image of the original function, and then that thick blue marker then is going to end up being the equation of the inverse function. Anybody struggling? Did you guys get your mirror to work? Did you get your marker to work? So put a brand new point somewhere on that green curve. Okay. Oh, no, you're doing a line, so get out of that and hit undo. There, okay, do a point. There you go. Lock it in right on it, point. Yep. Now mirror him. Use your mirror tool. Third one from the right.
This one?
Third one from the right. Yep, and click on, yep, reflect about a line. Yep. Click on your point C, and then click on your line. Now go back and get your pointer tool. Right click on C prime. Or, well, the other one. The mirror. Right click on him. Turn your trace on. And now drag your original point C. And notice how C prime draws. There you go. How we doing?
I don't know how to get that marker.
Do you have your mirror point? So go to C prime. No, right click on C prime. The other point. The other one. Right click on it and do trace on. There you go. Now drag. There you go. Drag. Perfect. Trace on. So yours is A prime or A prime. Right click on it. Turn the trace on. And now it'll trace as you go. There you go. Okay. Hopefully what you have figured out here now is this dark blue that I have up here. That is the graph of the inverse. So notice we haven't even done anything. We didn't do an XY switch. We didn't solve for the equation of the inverse. All we're doing is we're penciling out a graph of the inverse. Now I want you to go to the answer that you got, or the answer that you should have got when you did your Bellwork quiz, and you can type that in. The answer was the cube root of 2 times x minus 2. So you can do this either way. One is to go CBRT, and it shows cube root. So I'm going to hit enter, and inside the parentheses I'm going to do 2 parentheses x minus 2. I think that was our answer, right? And when I hit enter, notice that it gives me a new function. And notice that that function is exactly the same as that trace that your C prime was leaving when you were tracing. If you move your graph just a little bit, the trace goes away, and I moved mine a little bit. So if I turn my trace on, oops, I turned it off. Trace on. Now, notice how it's tracing right over the answer that I typed in. You got to go really slow on a tight curve there so you don't jump it. So it should be tracing over the one that you typed in. If you didn't type it in this way, the other way to type it in, I'm going to erase this one. The other way to type it in would have been parentheses 2, parentheses x minus 2, caret, parentheses 1/3. That's the exact same thing as, oh, I screwed it up. Did I not do 1/3? I screwed something up. 2x minus 2 caret 1/3. There it is. I don't know why that didn't work the first time. Notice it gives me the exact same thing. Was everybody able to produce the graph of the inverse? Okay. What I'd like you to analyze now is, let's look at our original. If I look at our original, if I draw a bunch of vertical lines, we can say, yes, it is a function, correct? Now I want you to look at this orangey red one. The one that we produced that we're calling the inverse. This one. The other one. Does that graph pass the vertical line test? It doesn't?
The green one?
No, my orange one. Is there any place where I would draw a vertical line where it would cut the graph more than once? Where?
X equals 2.
X equals 2? Nope. It's not gonna. Stretch it out and look. It might look like it's gonna, but it's not. For example, if I put in x equals 2 into that function, notice what's going to happen. If I put in x equals 2, it's going to be 2 minus 2 is 0. 2 times 0 is 0. And what's the cube root of 0? 0. There's only one answer. There's not 2. So I'll ask again, does my orange one pass the vertical line test? It does. So what does that mean? That means that it is a function. So I can say my original green one is a function, and not only is it a function, its inverse is also a function. They're both functions, right? We'll get to an example in a second where that's not necessarily the case. So back to what Hannah said earlier, how do we know if, let's say we didn't even have this guy yet. Let's say we didn't even have the graph of him yet. We didn't know him. Is this original guy a function? Yes. Is his inverse going to be a function? How can we test it? It's not the vertical line test. It is the horizontal line test. Because a horizontal line test on an original if I mirror it over, is going to be the vertical line test on the inverse. Does that make sense? So does this guy pass the horizontal line test? Yes, it does. And that's what we call a one-to-one function. Not only is it a function, but it's one-to-one. Every y value came from exactly one x value. There wasn't multiple x values that produced the same y value. So back to when we introduced functions and we did the what's your favorite movie and what does it start with? The movie function would not be one-to-one because there's lots of movies that start with the letter B, for example, right? So that would not be a one-to-one function. This one is a one-to-one function. So here's what I'd like you to try. Go ahead and give yourself a new screen. And this time, I want you to graph x squared. X squared. We know that that's a quadratic. We know that it looks like a parabola. Looks just like that. Give yourself the mirror again, that line. So you got to go make a line. And make sure it goes right through 0, 0. If you want, you can make it pretty again. I'm going to right click on mine. Go to properties. This time I'm going to make it, I don't know. I'll make it like a bright green. And I'll make it a little bit different dotted here. Okay. Go ahead and do the same thing. Put a point on your curve. I'm going to click somewhere right on my x squared. It's point C. Notice that, again, point C is locked in. It stays on the parabola when I drag it around. Mirror image him. Mirror image over your dotted line. And then turn the trace on for your mirrored point. Drag the original point and watch your mirror and watch what it draws. It should produce something that looks just like mine. Flag me down if you're not sure what's going on here. So if that was a piece of paper, if I folded it on the green line, the original would fold right onto that thicker blue one.
How do you get the C?
You got to mirror it. So go to your, yep, you got it. So click on C, then click on your orange line.
Oh.
Oh, click on C now. Okay, you got to do it one after another right there, and there it is.
Okay, there we go.
Yep. Now don't drag him. You won't be able to drag. Yeah, go. Oh, you were gonna. I see what you were gonna do. Yep. You were gonna right click on it. You won't be able to drag him though because he's defined to mirror C. So the only one you can drag is him, and he'll follow.
Okay.
Okay. Click on C, and then click on the green dotted line. Oh, it didn't work. Undo that. Use your undo arrow at the top. Okay. Click on that, reflect about a line, so it's highlighted, you're good. Click on C, then click on your green dotted line. There it is. Yep. Okay. Now, if you're getting it to produce the same picture that I did, you should recognize something about this inverse function that's different than the one that we did before. This one's not a function, right? Now, the original is a function. My purple one, x squared, is a function, is it not? That would pass the vertical line test. But if we said, what about his inverse function? That's this guy. It's still a relation. He still has an inverse. He just doesn't have an inverse function. Because what do we know about this blue markered one? He's going to fail the vertical line test, correct? So let's say we hadn't even drawn that yet. You could have figured it out before you even drew the inverse. We do the vertical line test. We say, yes, x squared is a function. How do we know if it's a 1-to-1 function or not? Or in other words, how do we know if his inverse is going to be a function? We would do the horizontal line test. Is he going to pass the horizontal line test? Of course not. You can see many areas where the graph would cut it more than once. So what does that mean? That means the inverse of x squared does not have a inverse who is a function. And you guys already know that because if you did it on paper, if f of x equals x squared, how would I get the inverse of him? What's the opposite of x squared? Square root of x, right? Well, we know that the square root of x, it's actually plus or minus the square root of x. For example, if I put 3 into x squared, my output is 9, because 3 squared is 9, right? Well, what happens if I put in 9 back into this? If I take the square root of 9, if it's plus or minus, if I want to get back to 3, but I'd also produce negative 3, right? There's two different ways to square a number to get 9, 3 and negative 3. So back to my graph. How could we fix that if we wanted to have an inverse function? Well, we would only be interested in half of my original function. I got to cut half of it off, right? If I could cut off this left-hand side, then it would not only still be a function, but then it would pass the horizontal line test, yes? So you guys might remember we've done this before. I'm going to click on my f of x equals x squared. And after it, I'm going to go comma. And I'm going to go x is greater than or equal to 0. And look what just happened to my x squared. See how I got rid of the left-hand side? How did I do that? I did it by restricting the domain. How did I do that? Comma, x is greater than or equal to 0. How did I get that greater than or equal to? Right here, there's that little menu where the alpha is. There's the greater than or equal to sign right there. You can just type it right in. So now that x is greater than or equal to 0, I got rid of the left-hand side of it. Now he passes the vertical and the horizontal line test. So now if I do my trace, notice his inverse is a function because I just kept the plus from the plus or minus. I got rid of the minus. So by restricting that domain, now I can say, yes, f is a function and f inverse is also a function. If I wanted to graph that f inverse, it'd be sqrt square root of x. Sqrt square root of x. Now I have both of them, the red one and the purple one. If I wanted to see the bottom half of this guy, I would have to do negative sqrt of x. There would be the bottom half, but I'm not interested in him. So I could toggle him off so he's not there. Comments? Questions? So what I would hope you'd be able to take away from this is you could look at any graph and you could immediately tell, is it a function? Yes or no? Vertical line test. Is it a function that has an inverse who's also going to be a function? Horizontal line test. You could tell instantly yes or no. And if you wanted to graph it, you could go through the shenanigans of using your computer if you wanted to. So this is very much related then to, remember I said we were going to talk about that last item on that worksheet that I gave you the other day? I'm not going to have you do it, but I'll just pull it up. Underneath 3.7, the exploration PDF, It was this one started out with Tracy's house on it. Way down at the bottom, it said, plots of f of x and g of x are shown below. Notice the symmetry of the two functions plotted together. You can see I got the dotted line in there. And then one is just a mirror image of the other. So you could change your x squared, your original function. You could graph any function you wanted to. And you could always produce the graph of the inverse just by doing our little drop and drag thing, even if you didn't know what the equation of the inverse was. Okay, now there's like 14 minutes left of class. So what I'd like you to do is keep in mind that your Chapter 3 test is going to be on Wednesday. So what does that mean? That means everything. Final due date is Wednesday. When I say everything, I'm referring to all of the OpenStax Blackboard quizzes, all of the Desmos, which most of you are done with all of them. Some of you might notice that in like a Desmos, it might have been like out of 5 points and you only got 4. Why? Because you either didn't finish it, or you didn't have one correct, or you didn't do something. So if you got less than a perfect score, you might want to check that out. You might want to go back into your Desmos and fix it. You can still access it. Click on the link. You can go back and pick up right where you left off. Some of you didn't even do some of the Desmos. That's why you have a 0 in there. Some of you didn't do the card matching worksheet. Some of you didn't do the genes, the successive discounts worksheet. I'd like you just to take a look at your grade book. See which grades are sticking out as either zeros or bad grades. Maybe you haven't finished your 3.7 quiz yet, or your 3.5 quiz. Maybe you haven't done as many attempts as you want to get the grade that you want. So I'm going to leave you some time to do that now if you want. If you're good and you're happy with where your grade book is and you're set, you're free to go. And I'll stick around for a while and answer any questions. Otherwise, we'll see you on Wednesday when you come to take your test. Okay.